what you're seeing right now, how the haze through greater distance distort the image or make it less contrast, while the closer part of the image is more contrasted. And the closer, that would be the bulge at around 12 kilometers. According to Anthony Riley, altitude was 13 meters. But then I received an argument, which is a good point, by Heath Carmody, and he's one smart flat earther, and he's really fair and what I can really call skeptic and critical thinker. So his argument was that the farther you look, let's look at the water line, maybe those 3 pixels at the water line are 50 or 49 or 45 kilometers away, and then if you get closer, like, or more down, few pixels down, the distance decrease increasingly. So I had to find a way to determine which point or what is the distance of the points we're looking at. So I made this diagram. On the left, the Isle of Man, and on the right, the observation point. The red triangle is the field of view of the camera. The black line is the eye level. The green line is the line of sight from the observation point until this part of the mountains of the Isle of Man. Right here is the lighthouse, and here is these mountains. So I went to Google Earth, and I got the elevation of this point above sea level. So now we have an angle here. This green angle is the angular size of the portion or the vertical portion of the image, starting from the water line until the highest point of the island above the lighthouse. So now I measured after that the pixels. This here, the green, this purple line represents my screen, and this purple line represents the field of view for the camera. So now I know how much pixels in this place, and then this distance, this black line, is the eye level and the 50 kilometers, and I know this altitude above the flat water because we're talking about flat earth. This is 13 meters at, say, 45 kilometers, and then this is 13 meters again at distance of 30 kilometers, and so on. And now I have an altitude and a distance, so I get an angle, and that angle I can translate it into pixels and measure these pixels from the eye level downward. So I made a spreadsheet. As you see here, this is the most important part. But first, let's check the distance. The distance to the mountain is close to 60 kilometers. The mountain height, sorry about the spelling, is 440 meters. Oh, excuse me. So the mountain angular size, according to these calculations, is 0.42 degrees, and I measured it on the picture in pixels. It was 80 pixels. the whole image is 768 pixels. But the important part is that we have 80 pixels represent 0.42 degrees. So we can get how many pixels in 1 degree. Then I put in equations here. The distance, 50 kilometers is maybe the shore or the lighthouse itself. So I thought to select 45 kilometers. The vertical angle from eye level to the distance on the screen or on the image in degrees is 0.02 and some fraction that doesn't show, and that equaled in pixels 3.15. So the total drop from eye level is 3 pixels, but the starting point was 461 pixels, so I add that number to 3.15 and it gives me the location of that distance on the image. And I just repeated the equations until distance of 5 kilometers, and here is the picture. Yeah, at this point I had to take down my video because I realized I made a couple of mistakes. One of them was insignificant, but the other was big. That I added cumulatively the pixel drop. So I repeated the calculations, and I put here is the correct picture. So the first line you see here, if you can notice, it's the black line which represents the eye level. Then next to it, this thick line represents the distance from 50 kilometers, that's the shore, until 20 kilometers away from the camera. The line right under it, which adjacent to that thick line, represents 5 kilometers on the scale, or on the image. Then after that, the line 15 to 10, and then 10 to 5 kilometers. I had to change the scale or the step to make it from 5 to 3, and then 3 to 2, and 2 to 1 kilometers. But if you look from starting from the island, or from the 20-kilometer mark until the 1 kilometer mark, it's the same contrast, which is an indication that the distance difference is not that much, that those points gotta be close. And I like to remind you that this image and the numbers are based on geometry of flat earth, so I'm presuming that this water surface is flat. So again, to sum it up, you see gradients in the contrast or the haze. This means there's a smooth transition of the distance. You see steps in the haze or the contrast. This means that the distances, there's a lot of difference between those distances. And again, I like to thank Heath Carmody for his encouragement to make me check things more. Thank you all for watching.